September 18th, 1944. Dawn broke across the rolling farmland east of Arracourt, France, painting the morning mist in shades of amber and grey. Oberleutnant Klaus Bäumer stood in the commander's cupola of his Panther Ausführung G, watching the fog slowly lift from the valley below. His tank, bearing the tactical number 231 on its turret, was barely 3 weeks old, delivered directly from the MAN factory in Nuremberg, with less than 40 kilometers on its odometer. The metal still smelled of fresh paint and cutting oil. Bäumer had been told by his battalion commander, during the brief pre-deployment briefing, that American Sherman tanks were inferior machines, under-armored and under-gunned, crewed by men who lacked proper tactical training. The Americans, his commander had assured him, relied on numbers rather than quality, throwing waves of mediocre equipment against German technical superiority. Bäumer had believed this completely. Why wouldn't he? The Panther beneath his feet represented the pinnacle of German armoured engineering, 80 millimeters of sloped frontal armour that no American 75mm gun could penetrate, a high-velocity KOK-42 gun capable of destroying enemy tanks at ranges exceeding 2,000 meters, and a Maybach engine delivering nearly 700 horsepower. What Bäumer didn't know what none of the young, hastily trained crew members of the 113th Panzer Brigade understood that morning was that tucked into the ammunition racks of the American Sherman tanks, waiting in defensive positions ahead were specialized rounds that would fundamentally alter the tactical equation. 6 M93 high-velocity armor-piercing rounds per tank, each containing a tungsten carbide core capable of punching through the Panther's gun mantlet at combat ranges that German doctrine had declared safe. The psychological impact of this ammunition would prove as devastating as its kinetic energy, shattering German assumptions about invulnerability and forcing a brutal recalibration of confidence that had sustained German tank crews since the invasion of France 4 years earlier. The story of how American industry solved the Panther problem begins not with the Battle of Arracourt itself, but with the crisis that emerged in the hedgerows of Normandy 3 months earlier. When Allied forces stormed ashore on June 6, 1944, American armor consisted primarily of M4 Sherman tanks, armed with 75mm M3 guns weapons that had proven adequate against earlier German armor, but were about to encounter a new reality. American intelligence had catastrophically underestimated both the quantity and capability of German Panther tanks that would be deployed in France. Pre-invasion estimates suggested perhaps a dozen Panthers scattered among German armoured units in Normandy. The actual figure was closer to 200, representing roughly 38% of German tank strength in the theatre. More troubling than the numbers was the performance. The Panther combined the Soviet 34's lesson of sloped armour with German precision engineering, creating a medium tank that outclassed anything in the American inventory. Its glacis plate, 80mm thick and sloped at 55 degrees from vertical, created an effective armour thickness of approximately 140mm. The Sherman's 75mm gun-firing standard M61 armour-piercing rounds could not penetrate this armour at any range, not at 1,000 meters, not at 500 meters, not even at point-blank range. The rounds simply bounced off, leaving bright impact marks on the steel, but causing no damage to the crew or systems inside. Meanwhile, the Panther's 75mm KUK-42 gun could destroy a Sherman from well over a mile away, its high-velocity armor-piercing rounds slicing through the Sherman's frontal armor as if it were sheet metal. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The first sustained encounters with Panthers occurred during the Battle for Caen in late June and early July, 1944. American tank crews found themselves facing an enemy they could not reliably defeat from the front. Sergeant Harold Fulton of the 2nd Armoured Division recorded in his diary on July 4th. "We hit a Panther 6 times from 400 yards. Every shell bounced off. Their first shot killed our tank. How are we supposed to fight this?" The psychological toll was immediate and severe. Tank crews who had trained for months, who had crossed the Atlantic believing in American industrial might and technical competence, discovered that their primary weapon was inadequate for the mission. Standard tactical doctrine emphasized frontal engagement using the Sherman's excellent gun stabilization and fire control. But frontal engagement against a Panther was suicide. Crews were forced to maneuver desperately for flank shots, exposing themselves to German anti-tank guns and infantry, while trying to reach firing positions where the Panther's thinner side armor might be vulnerable. Even this proved difficult. German doctrine positioned Panthers in hull-down defensive positions, exposing only the heavily armored turret while keeping the more vulnerable hull hidden behind terrain. American crews advancing across open ground had to close to within a few hundred meters before achieving angles where side shots were possible if they survived the approach. The crisis reached General Dwight Eisenhower's attention in early July. On July 2, 1944, field reports documented repeated failures of American tanks to defeat German armor. Eisenhower's response, witnessed by multiple staff officers, captured command-level frustration with weapons that were failing soldiers in combat. "You mean our 76 won't knock these Panthers out?" he reportedly asked his ordnance staff. "Why, I thought it was going to be the wonder gun of the war." The 76mm gun Eisenhower referenced was already in production. The M1 high-velocity 76mm gun had been developed specifically to give the Sherman improved anti-tank capability, and tanks mounting this weapon had begun arriving in England in April 1944. 130 M4A1 tanks with 76mm guns sat in British depots weeks before D-Day. Yet commanders had refused to deploy them on June 6, citing insufficient crew training time, logistics concerns about supporting two different ammunition types, and confident assessments that the 75mm gun would prove adequate. This decision would cost American tank crews their lives. By mid-July, the inadequacy of the 75mm Sherman was undeniable. On July 12, a board of senior officers formally confirmed what tank crews had been reporting for weeks. American armor could not defeat Panthers frontally with existing weapons. General Omar Bradley immediately ordered 76mm Shermans rushed from Britain to frontline units. On July 25, during Operation Cobra, the breakout offensive from Normandy, 102 M4A1 tanks mounting 76mm guns entered combat for the first time. The initial results, while better than the 75mm gun's performance, remained sobering. The 76mm M1 gun firing standard M62 armor-piercing capped rounds could penetrate 109mm of armor at 1,000 meters when striking at 0 degrees obliquity perpendicular to the armor surface. Against earlier German tanks like the Panzer IV, this was more than adequate. Against the Panther's sloped glacis plate, it remained insufficient. The effective armor thickness of the Panther's frontal hull exceeded the 76mm gun's penetration capability at combat ranges. Crews discovered they could penetrate the Panther's gun mantlet, the curved piece of cast steel protecting the gun mount, but only at extremely close ranges, typically under 100 meters. At such distances, the Panther's overwhelming firepower advantage made engagement a desperate gamble. A Sherman crew might get one shot before the Panther's return fire destroyed them. The solution emerged from American ordnance laboratories, where metallurgists and ballistic engineers had been working against time to address the penetration problem. The T4 round, later standardized as the M93 HVAP high-velocity armor-piercing, represented a fundamental departure from conventional armor-piercing projectile design. Traditional armor-piercing rounds consisted of hardened steel projectiles, designed to punch through armor, using kinetic energy. The projectile's mass and velocity determined penetrating power, with denser materials and higher velocities producing better results. But there were limits to how much velocity could be achieved with steel projectiles of a given diameter. The 76mm gun's chamber pressure and barrel length constrained muzzle velocity with standard ammunition to approximately 792 meters per second. The breakthrough came from materials science. Tungsten carbide, one of the hardest substances available, possessed a density nearly twice that of steel. By using a tungsten carbide core surrounded by a lightweight aluminum body and ballistic windshield, designers could create a projectile that concentrated maximum kinetic energy into a smaller, denser penetrator while reducing overall projectile weight. The lighter projectile achieved dramatically higher muzzle velocity from the same gun, 1,036 meters per second, compared to 792 for standard ammunition. This 244 meter per second velocity increase translated directly into penetrating power. The physics were elegant. Kinetic energy increases with the square of velocity, so the higher velocity HVAP round delivered significantly more energy to the target. The dense tungsten carbide core, being harder than armor steel, was less likely to shatter or deform on impact. The small diameter of the penetrator concentrated energy into a smaller area, increasing pressure at the point of contact. According to official War Department testing data conducted at Aberdeen Proving Ground, the M93 HVAP round could penetrate 160 mm of armor at 1,000 yards, approximately 914 meters, when striking at 10 degrees obliquity. Against the Panther's gun mantlet, which consisted of 100 mm of curved cast steel on early models and 120 mm on later Ausführung G variants, this meant reliable penetration at ranges up to 1,000 meters. For Sherman crews who had been forced to attempt suicidal point-blank approaches, this represented a revolutionary improvement. But developing effective ammunition and producing it in quantities sufficient to affect battlefield outcomes were entirely different challenges. The HVAP round's effectiveness depended entirely on tungsten carbide, and tungsten was among the war's scarcest strategic materials. Before 1941, China produced approximately 36% of global tungsten supply. American domestic production from limited deposits in Colorado, Nevada, and California supplemented Chinese imports, but total availability remained severely constrained. Tungsten was critical to numerous war industries. Machine tool manufacturers needed tungsten to produce the cutting bits that machined aluminum aircraft components and hardened steel tank parts. Armor plate manufacturers used tungsten in heat treatment processes. Artillery shells, anti-tank gun ammunition, and now tank ammunition all competed for the same limited tungsten supply. Each 76mm HVAP round contained approximately 0.8 kilograms of tungsten carbide. A Sherman tank carrying the standard load of 6 HVAP rounds required nearly 5 kilograms of this precious material. Multiply that across hundreds of Sherman tanks, thousands of anti-tank gun rounds, tens of thousands of artillery projectiles, and millions of machine tool bits, and the scale of demand becomes apparent. The United States Ordnance Department had been experimenting with HVAP projectiles since spring of 1942, but production at meaningful scale didn't begin until after the Normandy landings revealed the extent of the Panther problem. In July of 1944, American factories produced approximately 1,000 rounds of 3-inch HVAP ammunition for tank destroyers. August saw the first meaningful production of 76mm HVAP, 1,000 rounds total. September yielded another 1,076mm rounds. These numbers, while representing significant industrial effort, were utterly inadequate for the scale of armoured combat unfolding across France. Not until November of 1944 did monthly production reach 5,000 rounds for the 76mm gun, ramping to 7,000 rounds per month by January of 1945. By March of 1945, approximately 33,000 rounds of 76mm HVAP ammunition had been produced, a fraction of what frontline commanders requested. The allocation system created painful prioritization decisions at every command level. Tank destroyer battalions, whose specific mission focused on defeating enemy armor, received preferential allocation. M18 Hellcat and M10 Wolverine tank destroyers mounting 76mm guns were issued HVAP rounds before Sherman tanks received them. This made tactical sense. Tank destroyers were designed specifically for anti-tank combat, but created operational frustration. Sherman tank battalions, which actually encountered German armor more frequently due to their combined arms role supporting infantry advances, often received minimal HVAP allocations. By February of 1945, the average 76mm Sherman in Europe had received a total of 5 HVAP rounds, 5 specialized rounds to face an enemy deploying Panthers as the standard tank in panzer divisions. A Sherman company with 17 tanks would possess 85 HVAP rounds total, while potentially facing German units fielding 30 or more Panthers. company commanders were forced to make agonizing decisions about which tank crews received how many rounds, knowing that miscalculation could cost lives. The first significant shipments of HVAP ammunition reached forward units in August of 1944, but distribution remained chaotic. Some battalions received substantial allocations they couldn't immediately utilize due to static defensive positions. Other units engaged in heavy combat exhausted their meager supplies within days and received no resupply despite urgent requests. The logistics network, already strained by the rapid advance across France and the challenge of supplying armies hundreds of kilometers from Normandy beaches, struggled to prioritize specialized ammunition amid competing demands for fuel, food, standard ammunition, and replacement parts. Training on HVAP employment was minimal to non-existent. The ammunition arrived at frontline units faster than training materials could be developed and disseminated. Many crews learned HVAP's capabilities and limitations through combat experience, sometimes successfully, sometimes tragically. Crews that fired HVAP at Panthers beyond the ammunition's effective range wasted scarce rounds and often provoked return fire from German guns that remained deadly at much longer ranges. The effective range against Panther mantlets was approximately 1,000 meters. Beyond this distance, projectile velocity decreased to the point where the tungsten carbide core could shatter on impact rather than penetrating. The core, while extremely hard, was also inherently brittle. Below certain impact velocities, approximately 700 meters per second at the target, the core fragmented against armor rather than punching through. This meant HVAP effectiveness declined sharply at longer ranges where velocity had bled off. American tank crews had to learn these limitations under fire, developing an intuitive understanding of when HVAP would work and when it wouldn't. By September of 1944, the strategic situation had shifted dramatically. Allied forces had broken out from Normandy and were racing across France. General George Patton's Third Army had advanced aggressively eastward, its armoured spearheads stretching supply lines to the breaking point, but seizing critical terrain before German forces could establish coherent defensive lines. On September 12th, elements of the 4th Armoured Division, one of the most effective American armoured formations, seized a bridgehead over the Moselle River near Arracourt, a small town in Lorraine approximately 40 kilometers from the German border. The bridgehead represented a dagger aimed at the industrial heart of Germany. If Patton's armour could cross the Rhine River and penetrate into Germany proper, the war might end before winter. German High Command recognized the mortal threat. General Hasso von Manteuffel's 5th Panzer Army received orders to counterattack, destroy the American bridgehead, and push Patton's forces back across the Moselle. The German force assembled for this mission included two newly formed panzer brigades, the 111th and 113th, equipped primarily with brand-new Panther tanks driven directly from factories to the front. On paper, German superiority appeared overwhelming. The two brigades together fielded approximately 150 tanks against Combat Command A of the 4th Armoured Division, which possessed roughly 50 Sherman tanks. The 113th Panzer Brigade alone entered battle with approximately 90 tanks and assault guns, including 42 Panthers and 40 Panzer IVs. German planners anticipated rapid victory. The Panthers' technical superiority should compensate for any American advantages in logistics or air support. The crews were young and inexperienced. Yes, most had received only weeks of training before deployment, but the tanks themselves were nearly invulnerable to American fire. Or so German commanders believed. What those commanders didn't know was that American tank crews in the 4th Armoured Division had received small allocations of HVAP ammunition in late August. Not enough for sustained combat 6 rounds per tank on average, but enough to matter if employed correctly. More crucially, 4th Armoured Division tank crews were veterans. They had fought across France from Normandy, had learned to read terrain for tactical advantage, understood combined arms coordination, and had developed healthy respect for German armour without being paralysed by fear. They knew the Panther's strengths, but they also understood its vulnerabilities. The gun mantlet was a weak point. The junction between turret and hull could be exploited. The side armour was much thinner than frontal protection. And now, For the first time, they possessed ammunition that could penetrate Panther armor at ranges where engagement was tactically feasible rather than suicidal. The morning of September 19th began with thick fog blanketing the gently rolling farmland around Arracourt. Visibility was measured in meters rather than kilometers. German reconnaissance was effectively blind. The Panzer brigades, lacking proper scouting units due to the hasty manner in which they'd been formed and deployed, advanced into terrain held by American forces, who knew the ground intimately and had established carefully prepared defensive positions. At approximately 0800 hours, elements of the 113th Panzer Brigade penetrated American outpost positions east and south of Arracourt. The German tanks' factory-fresh Panthers, with fewer than 100 kilometers on their odometers, moved forward in column formation along approach roads. This was the first of many tactical errors that would characterize the German attack. Advancing in column through restricted terrain against an enemy of unknown strength and disposition violated basic tactical doctrine, but the inexperienced crews and their equally inexperienced commanders simply didn't know better. Captain Kenneth Lamisson's C Company of the 37th Tank Battalion held positions along key approaches to Arracourt. His Sherman crews had been briefed the previous evening on the HVAP rounds in their ammunition racks. The briefing had been succinct. 6 rounds per tank, tungsten carbide cores, effective against Panther mantlets and turret faces at ranges up to 1,000 meters, to use them wisely because there would be no resupply. Lamison had positioned his tanks in hull-down positions, taking advantage of terrain features that concealed the lower hull, while allowing the turret and gun to have clear fields of fire. This was textbook American defensive doctrine: use terrain to minimize your own exposure, while maximizing your ability to engage the enemy. The Germans, advancing in column on roads, had no such advantages. The fog that hindered German reconnaissance now worked decisively in favor of American defenders. A section of Lamison's Shermans occupied positions south of the village when the first Panther materialized from the mist at a range of approximately 75 meters. At this distance, the Panther's superior long-range gunnery meant nothing. The engagement would be decided by whoever fired first and hit accurately. The American gunner, Corporal James Mitchell, had his reticle on the Panther's mantlet before the German crew even registered the threat. Mitchell fired instantly. The HVAP round, travelling at over 1,000 meters per second, struck the curved cast steel of the Panther's gun mantlet slightly left of center. The tungsten carbide core punched through the 100mm armor as if it were paper, penetrating into the turret interior, where it detonated ammunition stored directly beneath the gun breech in-ready racks. The Panther exploded, not merely caught fire, but exploded its turret, lifting slightly from the hull as secondary detonations cooked off the remaining ammunition. Flames erupted through every hatch and opening. The crew had no chance to escape. 2 more Panthers emerged from the fog within seconds, following the leader in close column. Both were destroyed before their crews could effectively react. The second Panther took an HVAP round through the mantlet at 80 meters, with similar catastrophic results. The third Panther, recognizing danger too late, attempted to reverse but was struck in the turret face at a slight angle. The HVAP round penetrated, killing the commander and gunner instantly. The remaining German tanks in the column, shocked by the sudden violent destruction of 3 Panthers in less than 30 seconds, turned away and retreated into the fog. The crews were stunned. They had been assured that their frontal armor was proof against American guns. Yet 3 tanks had been destroyed from the front in the opening moments of combat. Throughout the morning of September 19th, similar engagements erupted across the Arracourt sector. American tanks, using the fog as concealment, engaged Panthers at close ranges where HVAP ammunition was most effective. The German tactical deployment proved disastrous. Advancing in column without proper reconnaissance, Panther crews repeatedly exposed themselves to American tanks positioned in carefully selected defensive locations. Near Arracourt itself, a platoon of M18 Hellcat tank destroyers, also equipped with 76mm guns and small allocations of HVAP ammunition, engaged German armor at close range. The Hellcat, with its open-topped turret and light armor, was vulnerable to any hit, but its speed and low profile made it difficult to acquire in the fog-shrouded terrain. The Hellcats crews used their mobility to engage Panthers from flank positions, striking side armor that even standard ammunition could penetrate, then repositioning before German gunners could return effective fire. By noon, as the fog finally lifted and visibility improved, the tactical situation had shifted decisively. American forward artillery observers could now coordinate fire missions with defending tank companies. Radio calls brought down concentrations of 105mm and 155mm artillery on German assembly areas and approach routes. The artillery didn't destroy many tanks. Direct hits were rare, but it disrupted German formations, damaged optics and external equipment, and killed or wounded exposed crew members. Then the fighter bombers arrived. P-47 Thunderbolts of the 405th Fighter Group, operating from forward airstrips in France, had been waiting for the weather to clear. When it did, they came in waves. The Thunderbolts dove through gaps in the thinning clouds to strike German armor with 5-inch rockets and 50-caliber machine gun fire. The rockets, while not powerful enough to penetrate Panther armor, could disable tracks, destroy optics, and wound crew members. The psychological impact was immense. German tank crews, trained to fight other tanks, found themselves under attack from above with no effective defense. The combination of American tactical advantages became brutally clear. While the Panther possessed superior armor and firepower as an individual weapons system, American forces employed combined arms tactics as standard doctrine. German tanks advanced without adequate artillery support, without air cover, without infantry to clear American defensive positions, and without reconnaissance to identify threats before blundering into them. American forces coordinated armor with artillery, air power, infantry, and tank destroyers in an integrated system that overwhelmed German technical advantages at every turn. When Panthers encountered these prepared defenses, they were destroyed piecemeal despite their superior individual capabilities. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The HVAP ammunition didn't make Sherman tanks equal to Panthers in technical specifications. The Panther remained objectively superior in armor protection, gun performance, and mobility, but warfare is not conducted according to technical specifications alone. Tanks are destroyed by crews who exploit vulnerabilities under combat conditions. The Panther's gun mantlet, necessary to allow the 75mm gun to elevate and traverse, created a known weak point. The junction between turret and hull, the side armor, the engine deck, all represented targets that HVAP-equipped Shermans could now engage successfully at combat ranges that previously had been suicidal. More devastating to German morale was the psychological impact of discovering their armor was no longer invulnerable. Panther crews had been trained to believe their tanks could not be penetrated frontally by American fire. Intelligence briefings emphasized the Shermans' inadequate firepower. Crews were explicitly told that as long as they kept their front toward the enemy, they were safe. The first Panther commanders to watch Sherman rounds punch through their mantlets and detonate ready ammunition learned otherwise. Those few who survived such encounters carried that knowledge back to their units, spreading awareness that American tanks now possessed ammunition capable of defeating Panthers frontally. By afternoon of September 19th, German tank commanders were sending confused and contradictory reports to headquarters. Some claimed the Americans had secretly deployed tank destroyers with 90mm guns. Others suggested the British had provided 17-pounder Firefly tanks to American units. A few reported that American Shermans appeared to be firing different ammunition that produced smaller entry holes and deeper penetration than standard rounds. All reports agreed on one critical point. American tanks were destroying Panthers from the front at ranges where this should not have been possible. The truth that American industry had developed specialized tungsten carbide ammunition that partially negated the Panther's armor advantage was more troubling to German planners than any of the theories circulating among frontline crews. It meant American industrial capacity could respond to tactical problems faster than German industry could counter them. It meant that the technological edge German armor had enjoyed was eroding not through battlefield capture or espionage, but through straightforward American engineering and industrial production. The fighting continued through September 22 when the major German offensive efforts finally stalled completely. American forces had destroyed or disabled approximately 86 German tanks and assault guns. American losses stood at 25 Sherman tanks and 7 tank destroyers destroyed or damaged beyond immediate repair. The kill ratio heavily favored the Americans, despite their supposed technical disadvantage in individual tank performance. The Battle of Arracourt represented not just a tactical victory but a psychological watershed. American tank crews learned conclusively that they could defeat Panthers without waiting for specialized tank destroyers or overwhelming air support. German crews lost the psychological security of believing in absolute frontal invulnerability. The Panther remained a formidable weapon, but it was no longer the invincible fortress that German propaganda and training had portrayed. The German perspective on Arracourt was one of confusion and bitter recrimination. The 113th Panzer Brigade, which had entered battle with approximately 90 tanks and assault guns, could muster fewer than 20 operational vehicles by September 29. German after-action reports struggled to explain the defeat. The technical superiority of the Panther was undeniable on paper: better armor, better gun, better mobility than the Sherman. How had inexperienced crews in newly produced tanks been defeated so comprehensively by an enemy using supposedly inferior equipment? The answers lay partly in training and experience. The Panzer Brigade crews had minimal training, often arriving at the front with only weeks of instruction on their vehicles. American tank crews in the 4th Armored Division were veterans who had fought across France, understood combined arms warfare intimately, and had learned to read terrain for tactical advantage. But training alone didn't fully explain Panther losses, particularly the penetrations that should not have been possible with standard American ammunition. German intelligence officers systematically examining destroyed Panthers found entry holes smaller than expected, suggesting sub-caliber projectiles. Examination of unexploded rounds recovered near disabled tanks revealed the truth. Tungsten carbide cores surrounded by aluminum bodies. The Americans had deployed specialized armor-piercing ammunition similar to Germany's own Panzergranate 40, but in quantities that suggested industrial production capacity Germany could no longer match. This discovery had profound strategic implications beyond the immediate tactical situation. Germany itself had pioneered tungsten carbide ammunition with the Panzergranate 40 series for anti-tank guns and tank cannons. But German tungsten supplies were critically limited by late 1944. Swedish imports, which had sustained German tungsten stockpiles earlier in the war, had declined sharply as Sweden recognized Germany's deteriorating position and reduced exports. German domestic tungsten production remained minimal. The Reich simply lacked significant tungsten deposits. By autumn of 1944, German industrial planners were desperately rationing tungsten for machine tools needed to produce aircraft engines and precision components. Ammunition production using tungsten had been largely abandoned due to material scarcity. If Americans could field specialized tungsten carbide ammunition in quantities sufficient to distribute to frontline tank units, not just elite formations or special weapons, but standard Sherman tanks in regular armored divisions, it demonstrated industrial capacity and resource access that Germany could not hope to match. German factories were producing Panthers with superior armor and guns, yes, but those tanks were being destroyed by American ammunition that German industry couldn't produce in equivalent quantities. The strategic mathematics were brutally simple. American industry could solve the Panther problem through ammunition development and mass production faster than German industry could develop countermeasures. The impact of HVAP ammunition extended far beyond the immediate tactical results at Arracourt. As word spread through American armored units that the new ammunition could defeat Panthers under favorable circumstances, tank crew morale improved measurably. The psychological paralysis that had affected some units during the difficult Normandy fighting began to dissipate. Crews still respected the Panthers' capabilities. No one became reckless or overconfident, but they no longer felt helpless when confronting German armor. This shift in morale had direct tactical consequences. A crew that believes it can fight will engage aggressively, seeking advantageous positions and taking calculated risks when opportunities appear. A crew that believes it's outmatched will hesitate, ceding initiative to the enemy. HVAP ammunition, though critically short in supply, provided American tankers with a weapon that allowed them to fight Panthers on more equal terms. Even crews that had never personally fired an HVAP round benefited psychologically from knowing the ammunition existed and might be available when most needed. The allocation system, managed at multiple command levels from army down to battalion, inevitably produced inefficiencies and frustrations. Some units received more HVAP than they could immediately employ due to static defensive positions or lack of contact with enemy armor. Other units exhausted their small allocations within days of heavy fighting and received no resupply despite urgent requests, because the logistics pipeline had no additional stocks available. Tank battalion commanders were forced into agonizing prioritization decisions. Should HVAP rounds go to the lead company most likely to encounter enemy armor first, or should they be distributed evenly across all companies to ensure everyone had at least some capability? Should veteran crews with proven marksmanship receive more rounds, or should inexperienced crews receive priority on the theory that they needed every advantage? There were no easy answers, and every decision carried the weight of knowing that inadequate allocation might cost lives. When German forces launched their surprise offensive in the Ardennes in December of 1944, the operation that would become known as the Battle of the Bulge, American tank units faced renewed intense pressure. The German attack employed hundreds of Panthers and Tiger tanks in winter conditions that favored defensive fighting and limited Allied air superiority due to persistent poor weather. American Sherman crews relied heavily on their scarce HVAP ammunition to engage German heavy armor when forced into direct combat. The shortage became critical within days. Some units exhausted their entire HVAP supply in the first week of fighting and found resupply requests going unfulfilled as logistical networks struggled to deliver specialized ammunition through snow-blocked roads disrupted by German advances. Crews reverted to standard ammunition and desperate tactics, attempting to disable tracks, calling for artillery support, coordinating with infantry bazooka teams, anything to avoid direct frontal engagements with German armor using inadequate rounds. Yet even in the difficult fighting of the Ardennes, American forces demonstrated that tactical skill and combined arms coordination could compensate for technical disadvantage and ammunition shortages. Tank crews worked closely with infantry, using bazooka teams to disable Panthers from close range, while Shermans provided covering fire and high explosive support. Artillery forward observers called in time on target missions that might not destroy tanks, but could damage optics, disable tracks, and kill exposed crew members. Air support, when weather finally cleared in late December and January, proved devastatingly effective against German armor concentrated on approach roads. The Battle of the Bulge ended with German armored forces shattered, having lost hundreds of irreplaceable tanks and experienced crews in an offensive that failed to reach its objectives or change the war's strategic trajectory. By early 1945, the strategic picture had shifted decisively and irreversibly in Allied favor. American and British forces were preparing to cross the Rhine into Germany proper. Soviet armies were advancing from the east, having shattered German defensive lines in massive winter offensives that liberated Poland and drove toward Berlin. Germany's industrial capacity was collapsing under combined strategic bombing, loss of territory containing critical resources and manufacturing facilities, and severe shortages of raw materials including fuel, rubber, and tungsten. Panther production, which had reached 3,900 units in 1944, fell sharply in early 1945 as factories were bombed. Transportation networks disrupted, and raw materials became unavailable. Even when Panthers were produced, fuel shortages often kept them immobile. German tank units in the final months of the war frequently abandoned tanks not because of combat damage or mechanical failure, but because they had no fuel to operate them or spare parts to repair them. The technical limitations of HVAP ammunition, while less publicized than its successes, deserve examination for complete historical understanding. The tungsten carbide core, while excellent at penetrating armor when conditions were favorable, was inherently brittle. This brittleness meant that below certain impact velocities, approximately 700 meters per second at the target, the core could shatter on contact rather than penetrating. As projectile velocity decreased with range, HVAP effectiveness declined significantly beyond 1,000 meters. American tankers learned these limitations through combat experience, sometimes at great cost. Crews that fired HVAP at Panthers beyond effective range wasted irreplaceable ammunition and often provoked return fire from German guns that remained lethal at much longer ranges. The effective engagement envelope required careful judgment close enough for HVAP to retain sufficient velocity for penetration, but not so close that the Panthers' overwhelming firepower advantage became decisive. Training on proper HVAP employment remained minimal throughout the war, as prapizos the tenium. Ammunition arrived faster than training materials could be developed and disseminated. Sergeant Francis Baker's documented experience on November 20, 1944, illustrated both the potential and limitations of HVAP under actual combat conditions. His Sherman, equipped with a 76mm gun and carrying 6 HVAP rounds, engaged a Panther at approximately 800 yards, roughly 730 meters. Baker's skilled gunner fired at least 7 rounds with multiple hits observed on the Panther's side armor. To Baker's immense frustration, the rounds bounced off without achieving penetration. The engagement demonstrated that even HVAP had significant limitations against sloped armor at oblique angles. At 730 meters, projectile velocity had decreased enough that the tungsten carbide cores were at the threshold of their performance envelope. Striking the Panther's side armor at an angle, rather than perpendicular, further reduced effective penetration. The Panther withdrew from the engagement rather than continuing the fight, so the action wasn't a complete tactical failure, but it reminded Sherman crews that HVAP was not a magical solution to all anti-armor problems. Proper tactics, careful shot placement, favorable range estimation, and advantageous engagement angles remained critical factors determining success or failure. The post-war analysis of HVAP ammunition revealed a clear pattern of effectiveness. Against the Panther's gun mantlet at ranges up to 1,000 meters, HVAP was highly effective when hits were achieved reliably penetrating and often causing catastrophic secondary explosions as penetrating fragments ignited ready ammunition. Against the glacis plate, results were poor except at very close ranges and favorable angles. The extreme slope meant that tungsten carbide rounds, traveling at high velocity, often ricocheted or shattered on impact without penetrating. This meant Sherman crews still needed to maneuver for advantageous shot angles and flank Panthers when tactically possible, rather than relying exclusively on frontal penetration capability. The ammunition didn't make Sherman tanks technical equals to Panthers, but it gave American crews a fighting chance in engagements where previously they had little hope of success. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.